questions are in the booklet for a reason. Like, this is the kind of stuff I need you to know. So if you go to 21 and you were to read this, okay? So Marie is a Métis beadboard artist, ordered packages of beads from 2 online companies. She's weighing the packages because of the sizes because the sizes seem inconsistent. The standard deviation of the masses of the packages are, so for A it's 11.7, standard deviation for package B is 18.2. So remember, grams, it could be grams, percentage, it doesn't matter. Whatever units we're dealing with, it could be age, right, height, it doesn't matter. In this case, we're talking about mass, so it's obviously in grams. So what does the information tell us about the dispersion of the masses of the packages in each company? So I will just give you my key here to look at, but right off the bat, you should be able to say that company A's packages are more consistent when it comes to the weight, okay? When you see a Coke can or pop can, they don't pay me to say this, Coke, Pepsi, C+, whatever, Crush. When they say 355 mLs on their can, that's an average, by the way. They don't always get it right on 355, right? And so their cans, they have a standard deviation that they're off by. But they want the standard deviation to be as small as possible to say most of the time we're really close to 355, all right, guys? That's what they're aiming for. And so your answer, right? The packages from company A are much more consistent and closer to the advertised weight or average weight, you could say that as well. The boxes have as many beads as advertised, basically, or closer to what the advertised weight is. What's B saying? Marie's working on an important project. She needs to make sure that her next order will contain enough beads to complete the project. Should she order from company A or B? Well, I think that's self-explanatory, right? But company A is probably best because then she can be more accurate in her ordering. She doesn't have to order too much extra because she kind of expects to have what she needs. Anybody done beadwork ever on moccasins or anything like that? Maybe not moccasins. I've done some of that. It's actually a lot of work. There's small, tiny beads, and you have to like thread your needle through it. It's pretty cool though. Even though there's a chance that the beads and packages from company B are far over the advertised amount, it is also possible that it is far below the advertised amount. That's what you need to know, right? So yes, there's a chance that you're way over what you need, but there's also a big chance that you're under, okay? Company A is better due to the low standard deviation. That's what you needed to know there, okay? And then question 5 on page 21. This is similar to the one I already gave you, the different athletes, right? But in this case, we have groups of students recorded their pulse rates. So there's group 1, 2, 3, 4, right? I need you to figure out, quite often you'll have to figure out the mean and the standard deviation of each group, okay? And so you do that. I strongly suggest you enter them into different columns like that. Don't erase, because you might have to come back to that to analyze it further. And it says, determine the mean and standard deviation for each group to 1 decimal place. Don't listen to that, it's always 2. Which group has the lowest mean pulse? And the lowest, obviously, you just go and say group 3. They have the lowest mean, right? Which group has the most consistent pulse rate? Group 4. How do you know that? It has the lowest standard deviation, okay? That is really it. And this would probably be beats per minute, okay? That's what this is. This is the unit that we would use here would be that. And I would be very specific on that. I'll give you a unit that goes with it, right? So make sure you don't forget that. Next, let's go to page 22. I want to explain this one. This is going to be, I'm going to AC you often on this kind of stuff, right? So what is this called? Frequency table. Mr. Dirksen, time out. Frequency tables have 3 columns, remember? Yeah, let's go, let's check that out. Page 15. You told us that frequency tables have 3 columns here, Mr. Dirksen. What's up with the 2? The tally column, is there for you as you're creating your table. This is on page 15. So normally when you're given the frequency table, this is redundant. This is not going to be there. It's just going to be the interval here and the frequency there. Okay, so don't let that throw you off. So when the frequency table, imagine somebody had like hundreds of data points and they've already cleaned it up and they put it into a table. They're not going to give you the tally in between. Okay, so make sure you understand that this is a frequency table. Frequency table. That one is 1 as well. This one is 1 as well. If I ask you to find the mean and the standard deviation of a frequency table, what do you need to do? First and foremost, when you have an interval like this, you need to find the midpoints. That's right. So there's no other way. There's no other way. You have to type this into you have to figure out the midpoints, okay, for every single interval. And quite often it is not that hard. Like you would know that between 8 and 10 it's 9, right? But if you forget, just add them up. 8 plus 10 is 18 divided by 2 is 9. Okay, so there you have your midpoints. It's 11 here, it's 13, and you will start to see a pattern. Oh, sorry, this is 23, sorry. 25, 27. So I know I'm repeating myself a lot, but we're going to shift gears after this, so I need to make sure you understand how to do these. You could graph this thing. You could do everything you want with a frequency table, all right? You got to make sure you put this into L1 and this into L2. The interval, you have to kind of find an average of the interval because you can't type in 8 and 10, right? You can't do that. So you figure out the midpoints. And when you do that, I'll give you the finished work here. Because I just want to clarify, the key is posted. But right, I did that already for both tables, and yes, they vary. They have different amounts of intervals. It doesn't matter. You treat it the same way. And I found the mean and the standard deviation for both, what are these, fitness clubs, right? So there's slightly difference in their standard deviation. You can tell that on average, Fit for Life, this one here, participants seem to work out more on average, more hours, but they're more inconsistent compared to Fitness Empire, right? So you got to be able to talk about the mean and about the standard deviation. And here is where I really need you to be able to graph them both at the same time, okay? Both at the same time, on the same grid to compare them. Just worry about one at a time, okay? How do you come up with your X values, folks? If you have a frequency table, it's honestly as simple as just grabbing those values. So for example, 8 to 10, right? 8 to 10, I just used that interval and I went 8 to 10, 10 to 12. It goes up by 2, which makes it a little complicated because in this case, I'm not gonna do this to you on a test, but I don't know if you noticed that this goes from 8 to 10, this goes from 6 to 9. So it's a little different, right? The midpoints are different, but that's okay. You still just kind of put them close enough to where they belong and you still get the marks. So you want to put the midpoint, so between 8 and 10 it's 9, right, for Fitness Empire, and I just connected those dots, the midpoints of them, to create my frequency polygon. Remember I told you could do a histogram. You could first do the bar graphs if you wanted, and then connect the middle of those bar graphs. That would also be fine. Then you do both at the same time. But you just got to be comfortable with that. And remember, what goes along your x-axis? whatever the interval is, whatever this is. This is hours, right? So in this case, obviously, it would be hours spent at the gym or working out. So that's what goes along the x-axis, hours training. And this would be, in this case, number of members, number of people. It doesn't matter to me, but that's what this would represent in this particular case. How do you come up with these? Well, you just have to look at the values that are given. So for example, if I look at Fitness Empire, I go all the way to 42, right? Versus Fit for Life, I go all the way to 52. So I had to make sure I went all the way to 50 and then some to make sure everything fit on my graph, okay? And one thing that I didn't add here is number of members. How could you find out the number of members for this fitness club? You should look at N value. When you come up with this, look at the N value. If I ever ask you how many members are part of Fitness Empire, you should be able to just add this up or just write down what N is. I don't know what it is right now, but that's what I mean. It's a frequency that will give you that number of customers, number of people, number of trees that were considered for this survey, and so forth. Okay, so you got to be able to do that. What does it say on the back side? Let's go to 23 real quick before I wrap this up, and then I'll give you a little bit of time to, I'll give you an AC that I will consider just class work, okay? So I know that at first it's going to be a little tough to get these right, the first round, but then tomorrow you come in and you get another one, and that's the one that's going to count. All right, so C on 23. The health club's believe that workout consistency is more important than workout length. Would you agree with that? Being consistent in your workout is better than doing, like let's say I did 5 hours one day and then 3 weeks nothing. And another person did every week 1 hour, right, for 5 weeks. Probably consistency is probably better for you, okay? Which club seems to encourage clients to be more consistent? Explain. I'm going to say Fitness Empire because how do you know? You always have to make reference to the standard deviation. A lower standard deviation, this indicates that members are more consistent in terms of the workout length. Okay, there we go. And then the twins, I think this one is very good to test your understanding. Twins Jordana and Jane wrote a total of 10 tests in math. Poor girls to be in that math class, right? 10 tests. Maybe you'll write about the same after all. 6 tests plus 2 cumulatives, that's 8. Final exam 9. Okay, they're all considered tests, right? Explain how this is possible that they have the same mean but different standard deviations. How is this possible? Okay, it is absolutely possible. The fact that they both have the same mean but standard deviation indicates that one of the twins was consistently scoring close to the mean, right? While the other may have scored far above or far below at times, or being inconsistent. So you can have Jordana like kind of spread it all out. This is the average, right? And Jane here had like, right, this is the average close to it, scoring very close to it. It's not as spread out as the other. That's how that works, okay? So standard deviation tells you consistency, even though you could have the same average. Consistency is very key. All right, so tomorrow we're gonna start, I'll give you a heads up already. Next class, if you go to 24, the bell curve, we're going to talk about that a lot moving forward. So we're almost switching gears, but not really. Like it's still part of what we've been doing, but we don't graph as much. We deal with the bell curve in general. So that's a highlight for tomorrow, okay? But right now,